Okay, 3E. 3E is for rationalizing the denominator. So what is rationalizing the denominator? If your denominator first, let's say we have a fraction 2 on root 3. Okay, if we have a fraction 2 on root 3, what is the denominator here? The denominator here is root 3. Like, real number can be classified into two groups, rational numbers and irrational numbers. Okay, root 3 is rational or irrational? Irrational. So this is irrational denominator. So what is rationalizing the denominator? It means I want the denominator to be a rational number, not irrational. Okay, I want the denominator to be a rational, not root 3. I want a 3 probably. So what is, like, why are we doing this? Okay, so like 2 on root 3 is still a correct number. There's nothing wrong itself with this number. But like say people would like to see the denominator into whole numbers. Okay, so that's something we looking for later in the course, like say math method. If you learn math method, all the questions will require you to give a not positive, integer number. Okay, I want the denominator to be 3. For example, 2 on 1.4 is not that great. Okay, we don't want 2 over 1.4. The denominator is not the whole number. We want to see the denominator as a whole number. Okay, so it's like looks neatly, I think it's more neat. So we want, like, what we can do to this question, we can do that become 20 over 14, and then I can do that 10 over 7. Okay, I can increase both top and bottom by 10 times, and then I will simplify it, divide by 2. So that's what we do for if we have a decimal denominator. Okay, so if we have root 3, which is irrational number, how's 3? Okay, 2 over root 3. Okay, 2 over root 3. How root 3 can become a rational number? Okay, so I can times another root 3 on both top and bottom. Okay, times another, times itself. Okay, times itself. Because a root, square it, that will become the number inside. So that will give you 2 root 3 over 3. 2 root 3 over 3. So it is the same number because I increased the top and bottom by the same number. Okay, times the same number. But the denominator become an integer. And I don't care about the numerator. Okay, the numerator can look whatever like you like. Okay, 2 root 3 is alright on the numerator. So denominator becomes 3. That procedure is called rationalizing the denominator. Okay, you make an irrational denominator become a rational denominator. Okay, that's what we talk about for 3E. So that's the whole idea for 3E. I don't want irrational numbers under the denominator. We want to make it become integers. Okay, so that is when you have a single number. That's an easy case, right? Yourself times yourself become an integer. That's easy. Okay, we have a couple of cases. Okay, we have a couple of cases. To convert the denominator from irrational to rational. Okay, look at this line. Number 1, if the denominator is a single term irrational. Okay, a single term irrational. So like root 3, root 5, okay, root 0.4, like it's a single number. Then we use the formula root x times root x equals to x. Okay, root x times root x directly get rid of the root that become rational. That is the case we just talked about. In the second case, it's a little bit different. If the denominator is with 2 terms, okay, the denominator if it's 2 terms, we will use the formula x plus y times x minus y gives you x squared minus y squared. Okay, give an example for that. If we have 1 over root 3 minus root 2. Okay, I can't times root 3 or root 2, right? There will still be one irrational number there. So what I'm trying to times will be root 3 plus root 2. Okay, it's minus root 2 now, right? I will do plus root 2. And on the top, I will times that as well. So what's the numerator become is root 3 plus root 2. What's the denominator becomes? Okay, a minus b times a plus b equals to a squared minus b squared. So a squared is 3 minus b squared is 2. That is 3 minus 2. Okay, so basically it's root 3 squared minus root 2 squared. A squared minus b squared. And that just gives you root 3 plus root 2. Root 3 plus root 2. Okay, if your denominator is with more than one terms, you use this way to rationalize that. Okay, well, all this is in this red box is quite useless because they all use the same thing. I'll just show you different cases. Okay, if you have a single denominator here, you times itself on both top and bottom. If you have two terms, okay, two terms, and two terms. Okay, even though for the first, second, third one, a is integer numbers like 4 plus root 3 like that. It doesn't matter. What you need to do is you times the negative, you plus and then you times your minus. A plus root y, you times a minus root y. A minus root y, you times a plus root y. You have root y minus a, you have root y plus a. You just have like minus the, like change the sign, okay, change the sign in the middle. And you have root a plus root y, you have root a minus root y. That's it. Okay, just change the sign in the middle. And you always, that all of this 4 is using the formula like a plus b times a minus b gives you a squared minus b squared. Because if you square the number, that will become integer for sure. Okay, that's just some examples to show you what to do. Okay. Have a look at the example. I'll just choose one example to do. Let's say we do this one. Let's say we do this one. Okay, first of all, what I can do to this one is, okay, there are more than one ways to do it. You can directly times root 70 and root 70 on both top and bottom. But what I want to do is 7 times root 9 times root 10 over 2 times root 7 times root 10. So the root 10 and root 10, they just cancel each other. And the top, you have that root 9 is 3. 7 times 3, 21 over 2 root 7. And now you can times, okay, it's a single denominator. Even though it's 2 root 7, it's one term, 2 times root 7. So you will times root 7. Okay, you times the only times the root. You don't need to times 2 root 7. Times root 7 is enough. Okay, times root 7 on both top and bottom. The top gives you 21 root 7. The bottom gives you 2 times 7, right? 2 times 7. Because root 7 times root 7 gives you 7. That is 1, that is 3. Okay, 21 and the 7, they can cross each other. And you have 3 root 7 over 2. 3 root 7 over 2. Okay, that's a single term. Okay, let's look at the next page. Let's look at the next page. Okay, the next page, you have square root on both top and bottom. Okay, I have on the top and bottom, but it doesn't matter. I just care about the denominator. And is the denominator a single term in this case? Is that a single term denominator? Yes. Okay, they're all single term denominator. Even though the numerator is not single term, but doesn't matter. I don't care about the numerator. I just want to change the denominator back to rational numbers. So let's do the second line. Okay, let's do the second line. This one. So what I will do is just times a root 6. On both top and bottom. Okay, times this root 6 on both top and bottom. What that equivalent to? That's 4 root 2 times root 6. That gives you 4 root 12 minus 5 times. Okay, let's not to do root 6 because what is root 6? I can make root 6 become root 2 times root 3, right? I can do root 6 is root 2 times root 3. It doesn't matter which way you do because I think that is easier. Why is easier? Because 4 root 2 times root 2 times root 3, the root 2 and root 2 will become 2. And 4 times 2 will be 8. So you have 8 root 3 minus 5 root 3 times root 2 times root 3. The root 3 and root 3 will become 3, right? 3 times 5 will be 15. So we have 15 root 2 over 6. Root 6 times root 6 will give you 6. So the answer will be 8 root 3 minus 15 root 2 over 6. Can I simplify anything? Is that possible to simplify? Can I do this? Can I do that? No, okay? Remember, I can't do that. If I want to cross out some number, it must be crossed out from every single term. Okay? 8, 15, and 6, they don't have anything in common, so I can't do that. Okay, back. We don't have that. Okay, that's the final answer. I can't simplify it. Okay, let's have a look at the next line. Okay, what we have here is I want to add 2 things together. Okay, I want to add 2 things together, but the denominator is different. I need to make a common denominator first. So what I will do is I will rationalize the denominator. That is 3 root 5 over root 5 times root 5, which is 5, plus root 2 over 2. Okay, I'll separately rationalize 2 denominator first. So first one become 5, second one become 2. What's the lowest common denominator for 5 and 2? 10. So I will make a common denominator first. So which is 10, I times 2 on both top and bottom. That will become 6 root 5 plus 10. I times 5, so it's 5 root 2. Now I have the same denominator here. I can add the numerator over 10. But because they are not like terms, root 5 and root 2, they are not like the same, so they cannot be added together. So that is the final answer. Okay, questions? Even though it's adding together, but they are still single term denominator. Okay, that's still single term denominator. The 5 and root 2 is not adding together. That belongs to 2 different fractions, add with single denominator. Okay, the last line. This is the two terms denominator. Okay, this is the two terms denominator. It's not single term anymore. Okay, one fraction with denominator 6 minus root 7. Okay, I'll show the middle one. 2 over root 11 minus root 2. Okay, 2 over root 11 minus root 2. So what I can do to that? That equals to, okay, I want to rationalize this. Okay, root 11 minus root 2. Okay, I will times what? I will change the sign and times them. So I will times root 11 plus root 2. Okay, on the top, I need to times that as well. That gives me 2 root 11 plus 2 root 2 over, okay, a minus b times a plus b. So it's a squared minus b squared. That is 2 root 11 plus 2 root 2 over, okay, root 11 squared is 11 minus root 2 squared is 2. So it's 11 minus 2. Over 9. Okay, the denominator become 9. Okay, this exercise is learn how to rationalize the denominator and how you can add between the two irrational denominator fractions. Okay, I'll give you. I will ask you to do the rest, but I will ask you to have a look at 3f. Okay, have a look at 3f. Do you remember we have learned 3f last year? Like all the law indices laws? Okay, we learned that before. So I'm not going to go through all of that, but I will go through negative indices with you carefully this year because I remember last year was terrible. Okay, the test was terrible. No one understands what is the negative indices. So I will go through the negative indices with you carefully this year. So, but the 5 laws we have before. First, we have a to the power of m times a to the power of n equals to a to the power of m plus n. So, for example, we have 3 to the power of 2 times 3 to the power of 5. That will equals to 3 to the power of 2 plus 5. They have the same base. You will add the power. So, same if you divide them, I will subtract the power. So if you have 2 to the power of 5 divided by 2 to the power of 3, that will equals to same base, different power. You divide, you subtract the power. That gives you 2 to the power of 2. Okay, law number 3. If you a to the power of m first and then the whole thing to another power of n, it will be the same as you times the power together. So 2 to the power of 4, the number to the power of 5, that will equivalent to 2 to the power of 4 times 5. That equals to 2 to the power of 20. And the zero power, what is zero power? Something to the power of 0. That is always equivalent to 1. One exception is we don't have 0, 0. 0 to the power of 0. We don't have that. If you put 0 to the power of 0 into the calculator, you will have undefined or like failed or like wrong or like typo or something like that. You can't have 0 to the power of 0. So anything other than 0 to the power of 0 equals to 1. Okay, equals to 1. Okay, next one is a times b to the power of m equals to a to the power of m times b to the power of m. So we have 3 times 2 to the power of 4. That will equals to 3 to the power of 4 times 2 to the power of 4. Okay, that's how you use the law. If you have something more, like say we have another number 2 times 7, then to the power of 4, you will be 7 to the power of 4 again. Not only 2 terms, if you have more terms times together to a power, you just to the power to all the numbers first and then you times them. And next one, index law 5. If you divide the number to a power, you like to the power first and then divide. So we have 4 to the power of 5 to the power of 2. That equals to 4 to the power of 2 over 5 to the power of 2. It will be 4 and 5 will be the same rule. 1 and 2 will be the same rule. Okay. 1 and 2 you will talk about that together, and 4 and 5 you will talk about that together. And also have index law 3 and plus zero power law. Okay, what is 0 power? Okay, the last one is negative indices. Okay, negative indices. Okay, what I can see last year, students make mistake because of what? Because okay, when you see 4 to the power of negative 2, directly they write like that. Directly put a negative sign in the front. But the negative sign on the power doesn't mean like you negative this number actually. That is still a positive number. The negative indice means you want to have a reciprocal number. You want to have a reciprocal. Okay, when you see the negative, if the power you see negative, yes, you see negative, you just write 1 over without thinking. Okay, without thinking. If there's a negative sign on the power, you just write 1 over. 1 over what? You will take off, you will hide this negative sign. Okay, you are left with 4 to the power of 2. And that's 4 to the power of 2. Okay, the negative do one thing, is the reciprocal. Okay, 1 over something. Over what? What is over is take off the negative. Yes? Like for example, negative 4 in the bracket or not in the bracket? No bracket? No bracket, let's say, and then it's negative 3, like that. So the negative is a negative 1. You don't really need to think about that. That's the actual negative in the front. And then the 4 to the power of negative 3, you will think about that is 1 over 4 to the power of 3. The negative is actually negative 1. You don't need to worry about that. Well, if in the bracket it will be a different case. Negative 4 to the power of negative 2, like that. Then that will be 1 over negative 4 to the power of 2. That will be a different case. Okay? Okay, so that is negative indices. And we have examples below here, but I'm not going to go through every single one with you. But one thing I want you to look at, you can do most of them, but one thing I want you to look at is example 16, which is page 12. Page 12. Okay, what I'm trying to do is I want to have all the positive indices. Okay, I want to make all positive indices. They're all negative indices, right? I don't want negative, I want positive. Okay, there's a quick way to do it. Okay, you have 5 to the power of negative 1, right? The negative 1 will be a 1 over 5. Okay, it will be a 1 over 5. Okay, it's on the numerator now. If you change it to the denominator, the negative sign can directly go. So what I will have for this one is, okay, 5 to the power of negative 1, right? If I want to be positive, it needs to be changed to denominator. So it will be the 5 here. And then we have h to the power of 3. It is already positive, stay as where it is. K to the power of negative 2. Okay, is that positive or negative? It's negative. I want to become positive. It needs to go down. Then that will become k to the power of 2. Okay, and now let's look at denominator. Denominator is 4 to the power of negative 1. It's negative. If we want to become positive, it needs to go up. So that becomes 4. M to the power of negative 2, it is denominator. It needs to go to numerator to make it positive. So it's m to the power of 2. And p is already positive indices. It just stay whatever it is. And that should be the final answer. If I do another example for you, okay, I have fraction. Okay, for this 4, the 4 should be here. T to the power of negative 1, which is not good, needs to go down. U to the power of negative 2, which is not good, go down, become U to the power of 2. 3 to the power of negative 1, not good, needs to change place to the top. V to the power of 2 is good enough, stay as there. W to the negative 6, which is negative, needs to go up. W to the power of 6. So it's 12W to the power of 6 over U T U V squared. Okay, that's a quick way to do it. Okay, that's a quick way to do it. Have a look at example 17. Have a look at example 17. 5 over 4 to the power of negative 1. Okay, 5 over 4 to the power of negative 1. What is it? That is, the negative will become 1 over. Okay, let's write a 1 over first. And then 1 over